The objective for this video is to find the distance between two polar coordinates and to graph two basic polar equations. All right, so first we're going to review law of cosines. We're going to actually use this to connect it to the formula to find the distance between two polar coordinates. So now, we have a regular triangle here, ABC. Remember, the capital letter, uppercase letters were our angles, lowercase letters were our sides. And you had to know that angle A is across from side A, angle B is across from side B, angle C is across from side C. Our law of cosines formula, it was a squared equal to b squared plus c squared minus 2 times bc times the cosine of the angle. So it was kind of easy to remember because if you start with if you start with side A, you have to have angle A at the end, and then B and C were just the other two sides. And then remember, if you wanted to solve for A, we had to take the square root of this whole thing. This was easy, we just had to type it in our calculator. All right, so now how does that connect to finding the distance between two polar coordinates? All right, so let's plot the polar coordinates to 150 degrees and 330 degrees. So remember, we go to a 150-degree line, count out a radius of 2, 1, 2, so that's my first point. Then I go to the 30-degree line, count out a radius of 3, 1, 2, 3, and right here. So what I need to do is find the distance between these 2 points. Well, let's draw in a triangle to help us figure that out. So when I draw in the triangle, I'm going to connect it to the origin, or in a polar graph, it's called the pole. And now I've got to fill in a few things. So let's kind of see if we can match it up to this triangle up here. So we're trying to find this side, so let's call that A. Then this is going to be angle A. These other two sides would be B and C, but I already have the length of this side. Since I counted out a radius of 3, this side is length 3. And since I counted out a radius of 2 over here, this side is 2. And I can easily figure out angle A. When I graphed 150 degrees, that would technically be from 0 over here would be 150 degrees. But I didn't start at 0, I started at 30. So to get angle A, all I have to do is take 150 minus 30 degrees. So angle A here is 120 degrees. All right, so now let's plug it in using law of cosines. Let me rewrite what we have. Well, A is what we're trying to find. B, and it doesn't matter 2 or 3, we'll just let it be 3. B we got from the first one of the radiuses. We counted it out, 3 radius, so B is 3, because that was one of the radiuses, technically radii. And then C would be the other radius, 2 squared, minus 2 times each of those radii, times the cosine of angle A, which we got angle A because we took each of the angles and subtracted them. All right, so let's just put that in our calculator. When you do distance formula for polar coordinates, your calculator mode has to be in degrees. So if it's not in degrees, change it. All right, so I'm just going to type it in. All right, looks right. 19. So a squared is equal to 19, so obviously we have to square root that. So a is going to equal 4.3589, and we're just going to round everything to one decimal place, so a is equal to approximately 4.4. Okay, now for the distance formula that we're going to use, we're not going to want to draw a triangle every time. So we don't need to do that. All we really need to know is that to get this 120 degrees, I took the angle that was given and subtracted it from the other angle. So that's all we really need to do. So here's the polar distance formula. It's going to be the square root. Each of these two sides we got because those were the radius. So that's going to be radius, the first radius squared, plus the second radius squared. Those two, that's where the 3 and the 2 came from, minus 2, that's always part of the formula, times the two radiuses, technically radii, times the cosine of the angle. And to get that angle, we had to subtract theta minus theta. I feel like the easiest way to remember that is to just say this theta is going to be the larger angle minus the smaller angle. So big minus little.